Have you ever picked up a simple rock and wondered where it came from? Or what incredible journey it might have taken to end up in your hand? Every stone has a story, but some stories are far more extraordinary than others. Most rocks we find on Earth are incredibly old, shaped by millions of years of wind, water, and time. But believe it or not, there are rocks that are even older than our planet itself, fragments that predate Earth by billions of years. Imagine a rock that has traveled across the vast emptiness of space, journeying for billions of years, surviving cosmic collisions and the freezing vacuum, before finally blazing through our atmosphere and landing on Earth. This is no ordinary stone. It's a true cosmic messenger, carrying secrets from the dawn of the solar system. This might sound like science fiction, but it's a real story. The meteorite in question is helping scientists rewrite what we know about how planets, including our own, first formed. Each fragment is a piece of a much larger puzzle. Think of this meteorite as a fossil, but not from a dinosaur or ancient plant. Instead, it's a fossil from the very beginning of our solar system, over 4.5 billion years ago. Its unique patterns and minerals are like time capsules, preserving the earliest moments of planetary history. By carefully studying its chemistry and structure, scientists can unlock clues about the conditions that existed when the planets were just starting to form. Each test reveals a little more about the birth of worlds and the violent, chaotic processes that shaped them. In a way, this tiny rock is like discovering the missing pages of a cosmic instruction manual, pages that help us understand not just how Earth came to be, but how all the planets in our solar system were born. And this isn't just any meteorite. It's an chondrite, a rare and special type that offers a direct glimpse into the earliest days of planet building. These meteorites are so uncommon that each one is a scientific treasure, revealing secrets that have been locked away for eons. So get ready to travel back in time, to an era before Earth even existed, and see how a small piece of space debris is challenging everything we thought we knew about our origins. This is a story of cosmic discovery, and it's only just beginning. Are you ready to join the adventure and witness how our solar system's history is being rewritten, one tiny rock at a time? Let's dive in and explore the incredible journey of this ancient messenger from the stars. Meet our cosmic celebrity, Northwest Africa 12,264, or NWA 12264. This unassuming rock has traveled across space and time to reach us, carrying secrets from the very dawn of our solar system. It's not just a meteorite, it's a messenger from a world that no longer exists. Discovered in the vast, sun-baked sands of the Sahara Desert, NWA 12264 might look like an ordinary stone at first glance. But beneath its weathered surface lies a scientific treasure trove, a time capsule that has survived billions of years of cosmic history. NWA 12264 is classified as an chondrite, a rare type of meteorite that comes from the crust of a long-lost baby planet, or planetesimal. This ancient world once had active volcanoes, and the rock itself is a fragment of its outer shell, formed in the heat of volcanic eruptions. Using advanced scientific instruments, researchers have probed the volcanic rock's structure and chemistry. Their analysis revealed that NWA 12264 formed on a world with dynamic geological activity, where molten rock once flowed and solidified billions of years ago. Through precise radioactive dating techniques, scientists determined that this meteorite solidified about 4.565 billion years ago. That makes it one of the oldest planetary crusts ever discovered on Earth, a direct link to the earliest days of our solar system. This remarkable rock is more than just a relic. It's a direct sample from the first generation of planets. In a sense, it's a true time traveler, bridging the gap between the ancient past and our present. NWA 12264 is a silent witness to a chaotic, fiery era when the solar system was young, when planetesimals collided, merged, and were sometimes destroyed in violent impacts. It preserves the memory of a time when worlds were being born and reshaped by cosmic forces. The age and unique composition of NWA 12264 make it a crucial key for scientists trying to unlock the mysteries of our solar system's earliest moments. By studying it, we gain insights into how planets formed, evolved, and what ingredients were present at the very beginning. So, NWA 12264 is not just a rock. It's a messenger from the dawn of time, carrying a story that stretches back over 4.5 billion years. Let's explore how this extraordinary meteorite is helping scientists rewrite the story of planet formation and what it reveals about our own origins in the cosmos. Before this meteorite, scientists believed in the nebular hypothesis. A spinning cloud of gas and dust formed the sun. Then planets grew from leftover material. Dust grains clumped together, forming pebbles, then boulders, then planetesimals, baby planets. The process was thought to be gradual and similar everywhere, with rocky planets forming close to the sun and gas giants farther out. The old model explained a lot, but left questions. Why are inner and outer planets so different? Why the asteroid belt? It suggested location was everything, but couldn't explain the sharp chemical differences in meteorites. It was like knowing two cities are different, but not why their cultures diverged. The story was neat, but something was missing. Scientists needed a new clue to explain the solar system's split personality. That clue was about to arrive. Scientists noticed meteorites fall into two families: non-carbonaceous, dry, inner solar system, and carbonaceous, wet, outer solar system. Non-carbonaceous meteorites are rocky and dry, formed near the sun. Carbonaceous meteorites are rich in water and organic molecules, formed far from the sun. The old theory said all ingredients were mixed together, but evidence showed two separate bowls. Something acted as a barrier, keeping these materials apart, a mystery called the isotopic dichotomy. The big question: what divided the solar system so completely for millions of years? Jupiter was the prime suspect, but scientists lacked proof and a timeline. They needed a smoking gun to connect the dots. That's where our meteorite comes in. Thanks to NWA 12264, we now see Jupiter as the great divider of our solar system. Jupiter's core formed fast, acting like a dam in the river of dust and gas, splitting the disk into two zones. Inside Jupiter's orbit, dry, rocky material built the inner planets. Outside, water-rich material formed the outer planets and asteroids. Jupiter's rapid birth supports the pebble accretion theory, where giant planets grow quickly by gobbling up pebbles. Jupiter's gravity didn't just divide, it protected the inner solar system, flinging dangerous objects away. Without Jupiter, Earth might have faced endless impacts, possibly preventing life. Our existence may depend on Jupiter's fast growth and its ancient divide. One giant planet shaped the fate of all the others. Why does this matter? Why should we care about a rock that's smaller than your fist, sitting quietly in a laboratory? Because this one small meteorite has completely rewritten the blueprint for how we think solar systems are built. It's not just a rock, it's a time capsule, holding secrets from the very beginning of our solar system. The idea that giant planets can form rapidly and carve up the disk of dust and gas explains the wild variety of exoplanet systems we see across the galaxy. Some of these systems have hot Jupiters, massive gas giants orbiting scorchingly close to their stars, while others are packed with super-Earths or mini-Neptunes. This new model, inspired by a single meteorite, helps us understand why there's so much diversity out there, and why our own solar system is just one of many possible outcomes. It also helps solve a long-standing puzzle about Earth itself. If our planet formed from dry, rocky material, as this meteorite suggests, then where did all our water come from? The answer is surprising. Earth formed dry, and only later did water-rich asteroids and comets crash into our planet, delivering the oceans we depend on, after Jupiter's orbit shifted and changed the flow of material in the solar system. This discovery is a powerful reminder that a single rock can force us to rethink everything we thought we knew. Science is always evolving, and sometimes the smallest clues, hidden in the tiniest fragments, can have the biggest impact on our understanding of the universe. NWA 12264 connects the atomic world inside a meteorite to the grand, sweeping scale of planet formation, bridging the gap between the microscopic and the cosmic. It's a powerful reminder that giant breakthroughs can come from the most unexpected places, and that sometimes the universe's biggest secrets are hidden in the smallest stones. What does this new timeline mean for Earth? Instead of a slow, steady formation, Earth's birth was shaped by Jupiter's dramatic actions. First, Earth's building blocks, non-carbonaceous planetesimals, formed quickly in the inner solar system. Jupiter's gap limited the material available, explaining why inner planets are smaller. The proto-Earth was hot, dry, and rocky, not the blue planet we know. Later, Jupiter and Saturn's shifting orbits sent water-rich asteroids and comets crashing in, delivering oceans and organic molecules. Earth's water and life-building ingredients were late arrivals, gifts from the outer solar system. Our planet's story is one of cosmic timing and interconnected events. The solar system's architecture made Earth's habitability possible. The story of NWA 12264 is an invitation to be curious. Every meteorite is a time capsule, a piece of ancient worlds traveling across space to tell us their story. Scientists are still searching for new meteorites, each one a potential key to our past. New technologies let us unlock secrets from even the tiniest samples. Missions like OSIRIS-REx bring back pristine pieces of the outer solar system, helping us complete the puzzle. By piecing together these clues, we learn not just how our solar system formed, but what makes planets like Earth habitable. The next big discovery could be lying in the sand right now. The universe is full of stories, and sometimes the biggest ones come in the smallest packages. All we have to do is look closely enough to read them.